Okay, welcome to Lecture Online, and the next section here is on the units of heat. Now, for us to be able to talk about thermodynamics, heat exchange, and all that, we really need to understand the units a little bit better. So, the main units that we use in thermodynamics is the calorie, the joule, and the BTU, also known as the British thermal unit. Now, of course, the BTU is not so much in vogue anymore in most places in the world, but you'd be surprised. In the United States, there's still a lot of places where we still use the BTU for thermodynamics, and we'll show you just in a moment why. All right, so let's start with the calorie. And the way that calorie is defined here, and be careful, do not confuse the calorie with the food calorie, because that's still a different kind of calorie. A food calorie is actually a kilocalorie, and we'll show you in just a moment what that is. But starting out with a calorie, let's say that we have 1 gram of water. Now, of course, typically cube, water is not in the form of a cube because water is a liquid, but let's just play along for a moment. Let's say that we have 1 gram of H2O. And let's say that the temperature initial is equal to 14.5 degrees centigrade. Because the definition is very, very particular here. If we add 1 calorie of heat to 1 gram of water that starts at 14.5 degrees centigrade, guess what will happen? The temperature will increase, the delta T will be exactly 1 centigrade degree, so that the final temperature will then become 15.5 degrees centigrade. Now, that is only true for that particular temperature change. It turns out at different temperatures, the delta T will not be exactly 1 centigrade degree. But for our purpose, typically, we don't really care too much about that. They just need to be known that it's very carefully defined to be the temperature change between 14.5 and 15.5 degrees centigrade. So, repeating, if you add 1 calorie of heat to 1 gram of water that is at 14.5 degrees centigrade, it will go through an exact temperature change of 1 centigrade degree and will then have a final temperature of 15.5 degrees centigrade. So it's the heat required to raise the temperature of 1 gram of water by 1 centigrade degree. And so in general, we'll leave out these specifics for our purpose. That's close enough. Now, a joule is a standard unit of energy. And so we need to be able to make an equivalence between a calorie and a joule. And it turns out that 1 calorie is equal to 4.186 joules. So sometimes the way we define a joule and the way we define heat added to water is if we had 1 kilogram of water, so that's obviously 1,000 times as much as we had over here. So 1 kilogram of H2O, and again at 14.5 degrees centigrade, but we'll leave that out for a moment. If we now multiply this times 1,000, so 1 kilocalorie is equal to 4,186 joules, and if we add a kilocalorie of energy, or this many joules of energy to water, then the temperature, the delta T, will also, of course, be 1 centigrade degree. We have 1,000 times as much water, we add 1,000 times as much energy, and therefore the temperature change will be the same. So 4,186 joules of energy added to 1 kilogram of water will cause the temperature to rise by 1 centigrade degree. And so they call that the specific heat of the water or any substance is the amount of heat that you need to add to the substance to raise the temperature by 1 degree centigrade. So for water, it's 1 calorie per gram or 4,186 joules per kilogram. So that's called the specific heat. So let's write that term down here somewhere. Let's put that down right here. So specific heat for reference. Now, where does the BTU come from? Well, it turns out that for BTU, they use something slightly different. They say, what if we had 1 pound of water? So 1 pound of H2O. And let's say that the initial temperature is equal to 63 degrees Fahrenheit, and the delta T is equal to 1 Fahrenheit degree, so that the final temperature is then equal to 64 degrees Fahrenheit. How much heat do you have to add? And of course, you already guessed that. You have to add 1 BTU of heat. So you add 1 BTU of heat to 1 pound of water at this temperature, initial temperature, the temperature change will be 1 Fahrenheit degree. Again, 63, 64 degrees Fahrenheit, which is fairly close to the centigrade degrees over here. We don't need to worry about that. Just ignore it. Just simply say that if you add 1 BTU to 1 pound of water, the temperature will go up by 1 Fahrenheit degree. And it turns out in the United States, when you buy heaters or water heaters or anything like that, or heaters for houses, they're still rated in terms of BTUs, how many BTUs per hour they can expel into your house or into the water heater. And so they've used those units for so long. Industry doesn't want to change, too expensive to change, so we still use those very old terminologies for very common household appliances that we still buy. You buy air conditioners, they'll say it puts out this many BTUs of cold air. It's a unit that will stick around for a while, at least in some parts of the world. So now you're familiar with the 3 main units of heat. And remember that this is all related to what we call the specific heat of a substance, but the definition is usually used for the specific heat of water.